Today in this lesson, we're going to learn about triangle similarity. But first, let's talk about what a similarity transformation is. Similarity transformations create figures that are the same shape, but not necessarily the same size. So we start with this figure. We can blow it up, reflect it, then perform a rotation, then shrink it, and we get a group of figures that are all the same shape, but not all the same size. These figures are all similar to each other. Let's look at another example. Here we have a figure. We translate it, then perform a reflection, and then shrink it. All of these figures are the same shape, but they're not all the same size. Again, this is a group of similar figures. Similarity transformations create figures that are the same shape, but not necessarily the same size. They include translations, reflections, rotations, and dilations. Notice that translations, reflections, and rotations give us congruent figures. But congruent figures are also similar figures. They just have a scale factor of 1. If we add dilations to this list, this gives us all the transformations that produce similar figures. If two triangles are similar, corresponding angles are congruent and corresponding sides are proportional, which means they are related by a scale factor. So here on the right, we have triangle ABC, triangle DEF. And if we know that triangle ABC is similar to triangle DEF, and by the way, this is the symbol that we use for similarity, it follows that angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F, and then the ratio of the corresponding sides is equal. This is another way of saying that sides are proportional, corresponding sides are proportional. It's another way of saying that corresponding sides are related by a scale factor. Now, it's also true that if we have this set of information, that all of the corresponding angles are congruent and all of the corresponding sides are proportional, we know for sure that we have similar triangles. But it's not necessary to have all of that information. There are 3 shortcut conditions that prove triangle similarity. AA, which stands for angle-angle, SAS, which stands for side-angle-side, and SSS, which stands for side-side-side. Let's first look at the angle-angle condition for triangle similarity. So here we have 2 triangles with 2 pairs of corresponding angles that are congruent. And what we see is we can perform a similarity transformation that maps one triangle onto the other triangle. And this is showing a translation, rotation, and dilation that maps the triangle on the right onto the triangle on the left. Now we can do this again. We slide, rotate, and dilate the triangle to map the triangle on the right onto the triangle on the left. We're always going to be able to do this when we have 2 pairs of corresponding angles that are congruent. Here is the statement of the angle-angle condition for triangle similarity. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. In other words, if we have two pairs of corresponding angles that are congruent, we know for sure the triangles are similar to each other. Let's look at the SAS condition for triangle similarity. So before I play this video, I want to point out to you that here we have a side of length 10, a side of length 30, a side of length 5, a side of length 15, and then included angles that are both 45 degrees. So notice that 10 and 30 are related by a scale factor of 3. 5 and 15 are related by a scale factor of 3. So this is what we mean by SAS. We have a pair of corresponding sides that are proportional, another pair of corresponding sides that are proportional, and an included angle, a pair of included angles that are congruent. So notice what happens. We slide, rotate, and then dilate to show through similarity transformation that these triangles are similar to each other. We can map one triangle onto the other triangle by a sequence of translations, a translation, a rotation, and a dilation. So if we change the side lengths, this is still true. We slide, it looks like we're adjusting the triangles again. Okay, we slide, and then change the scale factor to 1 to show that we can map one triangle onto the other triangle, which tells us that these triangles are similar. Here's the statement for SAS similarity. If two pairs of sides are proportional and the included angles are congruent, then the triangles are similar. So the way that we recognize this is corresponding sides, two pairs of corresponding sides are related by the same scale factor. And then the angle in between those pairs of sides are congruent. The pair of angles is a pair of congruent angles. So that was SAS similarity. Now let's look at SSS similarity. So here we have two triangles and three pairs of corresponding sides that are all related by a scale factor. So notice as we slide the scale factor, the ratio of corresponding sides is the same for all three pairs of corresponding sides. And we're able to show through a similarity transformation that these triangles are similar to each other. We're showing that if we perform a slide, rotation, and dilation, we map one triangle onto the other triangle. Here's the statement for the SSS condition for triangle similarity. If all three pairs of side lengths are proportional, meaning related by same scale factor, then the triangles are similar. So the way we can recognize this is if we take the side lengths for one triangle and the corresponding side lengths in the other triangle, and when we divide a side length by its corresponding side length in the other triangle, if we always get the same scale factor, we know for sure that those triangles are similar by SSS similarity. Okay, it's time for some practice. Complete each Khan Academy practice assignment linked below. Keep practicing until you get your score up to 80%. Take screenshots of your scores and insert them on the next slide.